Welcome back for this second part of the second lecture of this mini course. And the next goal proof of the C0 a priori estimates for the continuity path T R phi minus R equal to 1 minus T trace phi omega minus n, when T is in an interval between some positive epsilon defined by the initial data and 1. Great. So here we are gonna face another feature of the continuity path that was tailored by Professor Chen Shusho in 2015 to tackle the problem. Namely, we rewrite the path as a system of two PDEs The first PDE is a non-degenerate Monge-Ampere equation, and I believe Professor Pingali will say a lot about this. And so f is a function that should be linked to the path in the following way: minus the average of the scalar curvature minus 1 minus t over t. No problem about divided by t because of this domain of definition, trace of according to phi of omega minus n plus trace according to phi of Ricci. In fact, okay, so Ricci phi minus Ricci is minus square root minus 1 partial bar logarithm of omega phi to the n over omega n. This is a basic identity for used a lot in the Calabi conjecture, and R phi is the trace according to phi of Ricci phi. So this can be written as trace of phi. From here, this we see Ricci, trace is additive, so plus trace of phi of partial, minus square root of minus 1 partial bar of logarithm of this ratio, and from the first equation we see this is capital F. So we take the sign of the Laplacian to be such that this is minus Laplacian of phi over x. So it's the metric Laplacian. Great. So we set. Now we see that this is using this and the continuity path, we get the second equation over here. Great. So we have this equivalence. We set minus lower f defined as minus average of r plus 1 minus t over t times n, and eta to be defined as the 1-1 form given by Ricci of the background metric minus 1 minus t over t times omega. So the system becomes first equation is unchanged, there is a non-degenerate Monge-Ampere equation, and capital F is in the second equation is Laplacian of phi f equal minus f plus trace with respect to phi of eta. Great, so both f and eta only depend on the initial data and on the parameter of the continuity path. So if we want, we can emphasize t here, t here, t here, t here, t here, here, and here. The unknowns are f t, phi t and capital F t. Two unknowns for two equations. Both are second order elliptic. Okay. So this is the system which is present in the statement about the C0 estimates. Let's go to the statement. The statement can be thought of as a key lemma, if we want. Okay. So lemma which in the series of paper corresponds to theorem 3.2 second paper. Okay, define T as the interval, capital T is the interval epsilon 1. Okay, which is quicker to write down. For every okay, let's say for every for every small tau between 0 and 1, there exists a constant C3.6 depending positive only on the manifold G supremum over the interval of Ft C0 norm, the supremum of the norm of eta t with respect to the background metric, and the supremum on the interval of the entropy such that for any solution Ft Ft with maximum n of Ft is 0 of the system omega phi to the n is e to the capital F omega n, and Laplacian Ft Ft equal minus small f t plus trace Ft eta t, then the roles f capital Ft plus epsilon psi t minus, tau minus lambda phi t is bounded by this constant 3.6 for any small t in the interval capital T, where phi t is a smooth function of real values, satisfies maximum over n of psi t is 0, and omega psi to the n is the ratio e to the f t square root of f t square plus 1 over integral over m of e to the ft square root of ft square plus 1 integrated according to omega to the n times the integral of omega n over the manifold of omega to the n. So omega psi satisfies a Monge-Ampere equation with non-degenerate with this conformal factor for the volume. And finally, lambda depends on the same quantities as C3.6. Okay. Few remarks about this statement. This C3.6 is the classical appearance of a priori constant. So it's classical. I mean, as usual, it should be. It's meant to be positive. It's meant to depend only on some explicitly brought down quantities, and also is also meant to be bounded as long as those quantities are bounded. Now, these kind of data are also always bounded, and for here also we have no problem about the boundedness, and for the entropy we saw in the previous lecture that with the assumption on the properness, the entropy is bounded. So we are positive that this constant is also bounded. Now, this normalization is slightly different from the normalization H0. But we are gonna see that this is not a problem. I mean, we can play with normalization. For this kind of result, it's easier to first get a solution of this fashion and then change the normalization of this. So it's not a big issue about this normalization. But anyway, it's important to take account of this. This is the system, which is just the translation of the continuity path. Okay, and this is the main inequality we get from this lemma, and the C0 estimates will come from this inequality. The existence of such psi-t function comes from the solution, Yau's solution exists, psi-t exists by means of Yau's solution to Calabi conjecture. Okay. Okay, lambda could have been presented together with 3.6 anyway. It's there. Okay. If we are not frightened too much from this statement, we can move forward to the proof of this lemma. And in the proof we are going to drop the subscript t for convenience, and we just keep it in mind. Okay, the blackboard is not large enough to contain everything. Okay. Proof of the lemma. Let P0 be defined as the maximum argument, so the point where there is the maximum value of the function f plus tau c minus lambda phi, which is the function we want to bound. Now let U1 UL a finite holomorphic coordinates patch over the manifold. The local computations we are gonna perform are with respect to the coordinates coming from on these patches. Okay, so we will not mention orthonormal coordinates because we rather stick to holomorphic coordinates. Okay, now we claim, this is exercise. There exists a number d between 0 and 1/2 such that for every point on the manifold b over line is the ball of radius d and centered at P, closed, is contained in some UK k running from 1 to n. Hint, by contradiction. So using the compactness of the manifold, you can say that this is a uniform radius holding for every point for which this closed ball is in some, at least one of the holomorphic coordinates open sets. So now let key P in C smooth function on with the real values be such that the maximum over m of key, I'm dropping the subscript p, is precisely the evaluation at p is 1. It's a cutoff function. Then key, if we want key p restricted to the manifold minus b d of p is 1 minus delta with, sorry, theta to be determined. And so outside this ball centered at P, the The cutoff function is still positive, 1 minus theta is meant to be a positive number. 1 is the maximum, is inside, only at P, and the maximum over M of the gradient of P with respect to G is tan theta over D, this uniform number, while the maximum over the manifold of the Hessian with respect to G of T, the norm with respect to G, is less than 10 times theta to this over D squared. Okay. Now, okay, this is a cutoff function. Now we introduce an auxiliary, this function set capital A to be delta times the function in question in the statement, tau psi minus lambda phi, delta also to be determined, and notice that P0 was the maximum argument for this function, it's also the maximum argument for capital A, because delta is a constant. Now recall that, actually we should say a positive constant. Okay. Now we recalled the last piece of information is recall that preparing the gradient of a function u paired with the gradient of a function, the differential of a function v with respect to g can be written in this one of this patch as g a b bar times 1/2 u a v b bar plus 1/2 u b bar v a, and this is a notation we are going to use computing in coordinates. Okay, so as you may imagine, the proof of this lemma is gonna be quite lengthy. It's better to stop right now and to continue tomorrow. This is the very one of the most impressive achievements of the papers, because Chen and Cheng, they managed to prove such an important result by means of in a very clever application of classical results. So it's impressive and worth going in details through the proof. Thanks for your attention, and we will resume from this point tomorrow.